pause and copy all of this. Pause and copy, pause and copy, pause and copy. Okay. So we're going to let y be the temperature of the soup at time t. So initially, it's very hot at 100. And then 10 minutes later, it comes down to 60. Now the question is, when will it be 20 degrees? So we're going to make use of Newton's law of cooling, which says that the rate of change of temperature of our soup or object is proportional to the difference between the soup's temperature and the ambient or the surrounding temperature. So that makes sense. Okay, so the greater the difference between the soup's temperature and the water bath's temperature, the faster it's going to cool, right? And as it gets closer to 5 degrees, the rate of cooling is going to go down, right? So initially it's going to be very quickly cooling. Temperature is going to be descending quite quickly. 10 minutes comes down to 60. But to get down to 20, I think we're going to see that it's going to take quite a bit longer. And this makes sense, of course, because it's that difference that matters. Okay, so what do we get here? Well, as usual, proportional means that it's a constant times 1 minus 5. So we can separate. We go 1 over y minus 5 dy is k dt. And we integrate both sides, bringing us to ln of y minus 5. Y minus 5. Do I need absolute values? Let's see. Y minus 5. Is that positive or negative? Well, look, y is always quite a bit higher than 5. So I'm not going to need any absolute values there. Kt plus c. Okay, so I want to find constant k, constant c. I use my two pieces of information. So initially, temperature is 100, so we get beep bop bop beep bop boop beep bop bop. Ln of 95 is c. That's from this guy here, plugging in t is 0, y is 100. And then what else? Using this one, ln 55, 60 minus 5, is beep bop boop bop 10k plus c, which is ln 95. So I'm going to bring this ln over here. So I have a subtraction. And when you subtract lns, you can divide on the inside. So this ln came over here, so I had ln 55 minus ln 95, which, using log rules, gives me this. Let's reduce that fraction. What is that? Ln of 11 over 19. And then the 1 over 10 go in front. And there we have it. We have our k. And we have our c. And they are ugly as sin. So we'll just leave them as c and k in our future calculations, and then we will use our calculator if need be. Now, what am I doing again? Aha! I want to find when is the temperature 20. So I want to find t here from here. Okay, so there's no sense in solving this for y. Okay, a common mistake people make is they just blindly solve for y here, but there's no need in this case. Okay, I want to find there's a t value I'm looking for, and t is quite available here. So I would solve this for t here. What do you get? T is equal to ln y minus 5 minus c all over. Okay. Plug in y is equal to 20, and also the c and k values that I found here. And this gives me some number which is escaping me. Let me look at my phone here. $33.77 minutes, so approximately $33.77 minutes. So again, it took to drop 40 degrees. It took the first 40 degrees to drop the first 40 degrees. It took 10 minutes. To drop another 40 degrees required almost 24 minutes. And again, this is sensible because as the temperature of the soup and the temperature of the water bath get closer together, this cooling effect is going to slow down.